What's our one? Really? What? Oh, right, yes, I remember. Okay. Welcome to Amberskies, the place where we're going to make a 3D. Yes, 3D. Oh, not a virtual reality, but more of a browser, a network, a game, everything together type of thing. The whole kit and caboodle. Why limit ourselves? Why do anything different? My name's Fraser Sharp, and well, just call me Blades, and I'll be happy with that. And we need to get set up and started today, don't we? Yes, we do. So we're going to do the game foundation, and this means changing, well, a lot of our foundation, to be quite honest with you. We'll get rid of that. Yes, we can. Hey, that's ace. So, 11th of May we started this, and we are now on the 2nd of June. Oh dear, I've just got my dates wrong on this video, haven't I? I'll change the date over on the video after. That's perfectly fine. So, let's start here. Right, what do I need? Right, let's start with OpenGL and get ourselves more up to date, because I was having problems with formatting the screen on a non-GPU system, and I had to use an awful lot of silly code to get it all, sorted out. And there is an easier way of doing it, of course. So research is research, and things can change, and things can be quite fluid, but we have a QSurface format, and it's part of the GUI system. So we should have it here. There it is, QSurface format. There we go. And all I'm going to do is I'm just going to call it format. Nothing special going on in this part of the system. But I didn't want to be doing this earlier, because we were still doing Amber 3D SL, which has now got to the point where it can be changed into a library, instead of being a static library, a dynamic library. So it's getting very, very close to being changed to a dynamic library. Yeah. That doesn't mean it's finished. It means it's past the 50% completion stage. I think that's a better way of putting it. By the time we finish this, the way that Amber 3D is working currently has proven test-wise that we can do what we want with it, and we can make things very easy for ourselves, or, well, might have to make things a bit harder for ourselves as well. But it's got to be fluid, and it is fluid, and we're just going to set our renderable type. So what we're going to be doing, we're going to have a QSurface format. This is more to do with cross-platform rather than anything else. I'm putting this in because we've got OpenGL here somewhere. There it is. And this sets it on all platforms. Yeah, and that's why I like Qt. Qt does it all for us in the background. What else do we need to do with it? We need to set the profile. So we can set our profile. we can have a Q surface. This is all part of the Q GUI application stuff. So there, Q surface format. Spelled that wrong. And we'll have core. We'll have the core profile for OpenGL. As we already know, that's what we want to be using. And all we have to do now is, what I've been doing all along, is setting the version. So we'll set the version, shall we? And this will help us with all those problems that I was having. I would prefer to have done this first, but I wanted to let you see the problems that I was encountering, and yeah, all the kind of things that I was messing up. Right, so that's okay there. So our window can now be just the window, or view, as we've called it here. But now we can use it a little bit more. What I want to put in here are two commands which we don't have. So we will be, no, I'll double strike them for now. No, I won't. I want to be able to set the format, and I want to be able to resize it. That's going to be important going down the road. So yeah. So we'll need a set format and a resize. Right, let's go to our window. And we'll save that. And we'll go to our window. Our window's going to change today. Quite a bit. Stripping it down a little bit, I think, is going to probably be the best idea. Alright, because of this. It's a bit heavy, to say the least, but we'll see what we can do. Alright, so I've got Q OpenGL window. Yeah, check. OpenGL functions, we don't really need it like that. We can, I'm just going to break that down. And we'll just break that down to that. Context stuff, I'm just going to remove because it is done for us. Surface is being done in main. Don't need. I'm not even sure we need the Q mouse and Q key event, but I'm going to leave those for a sec. And the model warehouse. Okay, I'm happy with that. I want to look something up. It's this event system. I've got Q mouse event and Q key event. And that just seems to me to be a little OTT. Okay, let's go into the help system. It lets us. A bit of a slow potato machine, this one, and I've done on purpose. Right, QT, Q. Ah, there we go. Expose. Let's have a look at this event system. Center windows. An area of the window is invalid. Otherwise visible, yeah. Yeah. Do we need it? Region is given in local coordinates. I'm going to keep that in the back of my mind. I'm not really too bothered with that at the moment. So, right. Yeah, I'm happy with what we've got here. So we've got initialize. Alright, so we've got the two sets of information there. Right, I think we might be able to do these direct. I think we can do these through Qt. Going back to main. Let's try just doing it through Qt first, so we don't have to mess up our 3D stuff. Yeah. Might be a better idea. I think we can do that. So it would be view. Set format. Yeah, we've got it. We've got it. And we can pop in here format. Brilliant. So that works. I'm also going to put in a resize. I think we can do it from here. Resize, yes we can. And we're going to have, let's start with 900 by 500. That's a nice scaling. Widescreen. That's a widescreen 9 to 5. 5 versus 5. Now we're allowed to show it. All of this has to be done prior to that show. And we can start. Okay. Right, yeah. So we can show it and then we can start the game. Yeah, I'm happy with that. Okay. That's a little bit more helpful. Because now we don't need all of this rubbish in here. So I'm just going to try taking this out first of all. Edit. Advanced. Toggle line comment. So we're taking that out. Oh, I put 900 by 500 here. So we can take those two lines out completely. They don't exist anymore. Okay, that's looking better. In initialize, we just need that. I am thinking of taking that out. I'm thinking of taking that out because it does it for us. Qt does that for us. This I want to replace with something else. Yeah, I think we'll do that now, once we're here. I don't like that, because it's not generic. Well, it is generic. It's generic because it's OpenGL, but as you've seen before, I've had problems getting it to show on the screen. Okay, I think we're okay with initialization. Our painting's good. Our resize is properly done. Got our mouse events, and then we just stop. Alright. Now, I Actually, that's looking okay. Where's our destructor? Here. We're only making a model warehouse. Is that correct? That is correct. We are hinging the whole thing around this model warehouse, which is probably going to disappear now. Oh dear. Oh dear me. No, because I think we're okay there. I think we're concise enough within here now for it to work. Right, so I've switched over on test game. Oh, by the way, the starting code was up on GitHub. My apologies. Today's code base is up on GitHub. Let me just find it for you. If you go to GitHub or Amberskies, it's at github.com Amberskies /Amberskies. Amberskies_QT /Amberskies_QT, and we are in the dev branch, so change it over and you'll find that I've done a couple of cleanups. I did 2 cleanups, getting rid of all warnings. Yes, that took a little bit of time, and left really everything else alone, because I wanted to show you rather than just, you know, mess about, as it were, off screen. Okay, I'm happy with that. Let's give that a test. Give us now a clean screen without any menus and things. Oh yes, and I think I changed the shader. Oh no. What did all of those? Window 3D line 88. Oh right. That is correct. Okay. Save that out. Of course. Let's see who else I've just messed up by doing that. See one change. Reference formal per. Okay. Window 3D CPP88 again. Model Warehouse 68. Okay, my bad. And that means I now need to change something here. There. I'm doing this on purpose. I want to get these changes done now before everything gets too complicated. So I'm just searching through and just changing everything. Okay. CPP 33. Okay, header file. Up here somewhere. There it is. All down to just functions, please. Thank you. I'll get them all soon. Okay, I've still got one left. Batch renderer. I want to do the model warehouse first. CPP 36. MGL. Yeah, we sent it onto the batch renderer, didn't we? Oops. Here we go. At least these are easy changes to make. I mean, it's just deletion of stuff. Save that. Batch renderer CPP. Here we go. That one there. But I want to do this mainly because this changes something dramatically. See, OpenGL functions will find and use your OpenGL, whereas OpenGL functions 3.3 core might in the future be unusable. And of course MGL goes through to draw color and draw texture. Okay. It's a simple change, but it cascades. I'm glad I'm doing it now. I want to get rid of all of this reference to a specific OpenGL. And we're going to let our computer, or the program, take that instead. There's something wrong there. I have. Alright, that's looking okay. Let's do a bit more in here and see what this will give us a better list of now what I've missed. This is why when you have a game company who's constructed a like game code that is set in stone, you're gonna get problems. Later on down the line, when, for instance, ray tracing has just come in this last couple of years. So of course any game that was made 10 years ago is now having problems because it can't ray trace. And this stops that problem. Literally dead. It means you can just change your OpenGL anytime you wish, and your shaders anytime you wish, and you can use them. It'll work because this is not specified or specific anymore. There we go. Everything's looking a lot happier now. Actually, I'll just do a build on this. I think that's going to be better. CPP 91 and 92 model warehouse. That is correct. That is the one that I left in. Okay. Lovely. I didn't leave that in. I want to know why those force lines are still there. That's good. There we go, shaders failed. GL frag color is deprecated after version 120. Finally, it's told me not to use it. I've put it in on purpose. This was supposed to happen ages ago. Oh, wow. You beaut. It should pick up on the other one as well. I put the other error in as well, didn't I? No, it's only complaining about GL frag colour. Wow. Well, okay. Alright. That I find amazing. Absolutely amazing. So, I don't understand why it's chosen now. Oh yes, I do know now. Yeah, because I haven't told it that it's using 3.3. Which is backwards compatible. That was the version that was backwards compatible, which is why I used it, of course. So we are looking at all of them, I suppose. Alright. So it's all our verts, I think. Basic vert is... No, it's frags that we want to do. Okay, let's clear this lot. We're up and running. But you can see how one simple change like that going generic has just broken our shaders. Could you imagine that on a massive, massive system? That would be disaster. So this doesn't exist anymore. So we are going to call it, it's in the frag thingy. So we will just, I'll just call it colour out. Oh no. Final colour. Yeah. So out. Colour is a vec4. Final colour. And that's the only change we need to make. Really, it's coming from the frag, so it should be F underscore final colour. Yeah, I think so. F underscore delete final colour. Yeah. In case you want to do anything with it afterwards, which you can, of course. Oh, I'm now live on YouTube. Hello, YouTube. Hiya. Oh dear. Right, I'm going to keep that variable the same through everything. So it hasn't picked up on GL position, but it's picked up on GL color. Interesting. So all the frags. That's uniform sampler V. That's your out. That's your F underscore final color. There we go. Save. Frag. Okay. A bit more complicated here. Let's do that. Go to the bottom. There we go. Texture frag. I do love this. I think it's fun. I think it's quite funny how OpenGL reacts to things. Because it changed so much over the years. They really did goose it up. I mean, it was perfectly fine the way it was. Why they had to take this out, I don't know. But they did. They said that the out colour was not to be specified by the graphics card. but it could be variable. Now let's pop it in here. But you can see how much work it is just to change a little bit. I'm glad I'm doing it now. Final colour. Still got simplified here. Yeah. I don't know why this isn't working. Oh, that's right, yes. Yeah. Doesn't matter. It's just one of those things. It's a Microsoft thing. So there we go. Doesn't matter if it works or not in here. That's another lump of changes we've gone through. Let's try again. Let's see what breaks now. Nothing. Okay. Okay. Yeah, that's working fine. Alright, output. Alright, what I want... No, there's those two warnings still in model warehouse, and I've marked them in. Down in the... Here we go. Right, well, World Builder's going to get goosed, innit? Because we're really going to mess this up. So do we still need that mouse position? Not sure. Not sure. I'm going to have a massive job putting delta time in now. It's complaining that we're not using the mouse position. It's not really needed. So I'm just going to pop you out for a second. If we can get this cleaned up properly. Right, that's that done. That's you done. What we're building at the moment. Yeah, Amber 3 DSL, please. And that alters window 3D, yeah. Correct. Okay, let's do a rebuild. No, let's just do a build. Let's clean up the build first and then do a rebuild. To catch all. Okay, we're looking good now. Rebuild that. Should be clean. Window height unreferenced. Model warehouse, CPP 91. Do the same. Why did I call it window height when it's width? I've done something wrong there. Huh? That don't make sense. Why did I have width in there? Well, that's wrong. Oh dear. Right. Yes, I'm actually correcting comments. My god. Let's now just try it now. Work. Alright, that looks good. Let's do a rebuild. Make sure everything is correct. Alright, I'm happy with that. Nearly. Am I actually? No, check menu isn't being used. Okay. Right, let's see if we have got everything right now. As we go back to our test game. Yeah, I'm coming back up there. So. Test game, run. Oh, force lines. So we're working, but we've got this force line issue, which we shouldn't have. I thought I'd taken it out. Can we rebuild and get rid of it? Please? Core SL. Common.h. Yeah. Core SL. Common.h. Whereabouts are we? 104. We should be close now. We should be close. Yay. Can't believe I've missed that. Unless we switched over. Ah, right, yes. Just realised why I missed it last time. All succeeded, 0 failed, 0 skipped, no warnings. Good. I'm happy to carry on now. So, our window 3D, is it going to change in any way? I don't know, actually. Let's have a look. Window CPP. Right. Interesting. Translations. Yes. I don't like some of this. Oh, I was going to do the version information, wasn't I? I'm just wondering whether to do it or not, because that really isn't part of what this should be really doing, but we've just changed it, haven't we? Yeah, we've just changed it. So, version information for OpenGL. I want difference. I want it done differently. Oh, that's what we're doing, isn't it? Get rid of you, get rid of you. So, OpenGL. Window. What I'm going to do is I'm just going to have a private function here. And it's going to be void. Print version. No, info. It's not going to take anything in. No. That's you done. Oh god, it's starting to do this now. Oh no. Ah. What? Why? There we go. Right, so what do we need? I would like the following information. I would like the OpenGL type, because there are different types. The queue, the graphics, string, yeah. The version, that's what it's about. What else will I need? And we may as well look at the profile as well. GL. Because we can. Okay. So GL type. Let's do that one first. What's that going to equal? That's going to equal our context. So it's this arrow context, but I just don't put the arrow in. So context, we'll have you. That's your function. Is right. Okay, we've got that one. So if that is true, we'll query that. So if it's true, we will have OpenGL. If you've never seen this kind of programming before, don't worry about it. I'll just guide you through this in a second. I don't usually use it, because it's what I call fancy C++ rubbish. It's an if statement, that's all it is. It's a different way of writing an if statement. What I've just written there is if context is OpenGLES, GLES, then GL type equals that, else GL type equals that. This is just shorthand notation for the whole thing. How you read your shorthand notation is, if this is true, then query return true, return false. So true, false. It's just dependent on that statement. So we're going to query that statement. Is it true? Is it false? And that's really all it is. But you've got to use a bool. Like, that's a bool. Open. It's just asking a question. That's all. So all we're doing is finding out whether it's OpenGL extended system, extension system, or OpenGL. I think that's macOS. ELES. Usually. Okay, GL version. How do we get that? Right, we are going to have to cast this, aren't we? I think we are. Right, that's an enum. It's a GLU byte star. OpenGL functions. Right, so it's returning a GL unsigned byte, which is an address. Probably. Or is it? No, it's just the actual version number. Of course, yeah. Right, we will reinterpret that one, I think. So, yeah. Reinterpret to a const char star, please, which we can use for a Q string to make it easier. I think it returns numbers or an address, so we'll have that. And it's just GL get string, as we already know. There it is. Found it. And GL version. There we go. That should do it. Again, more complicated than usual, but this is more final code writing. So now I can that's going to become that for now. Now I can now I know that I've got everything, so we're getting other bits and pieces in here. Right, what else can we do? We can get the profile information, but there are 3 different profiles we can have. So we can use a switch. I'm going to show you an idea. Okay, the hash defines, we haven't really used them because I don't like to use them. But you can, let's say, have a define, and we'll make it into a macro, and we'll call it case. Okay. Just case C. Okay. Now the command word is case, as we all know, in a switch statement. You have switch and then you have case. But what I would prefer to have is the case for Q surface format. It's not going to give it me, is it? Okay. Doesn't like this going into a hash define. Whoa. Then we want whatever C is. Then we want a colon. Then we want the GL profile. Which is what we want to get. I hate writing these. So this is what we're trying to get, the GL profile, and that will be equal to C, the variable C. And then at the end of a case, you always have break. Well, should have break. So that's the whole thing. That's a case block. Right, the other way of doing that is obviously having case. We have switch, don't we? So let's put the switch statement in. Switch. Format. And we want the profile, don't we? Yeah, format. Profile. Yeah, we can have that. We can switch between the profiles. And normally in a switch statement it would be case space, and then we would have that bit. Let's say no profile. This is how you do it in longhand. And it's not coming up for me. It's there. So that goes like that. And then it's a colon. If I can remember rightly. There we go. I don't think we have that in actually. And the case would be the GL profile. Would equal no profile. So it'd be that repeated. What does this give back? It's an enum, no profile. Well, it gives back a 0. So if case 0, GL profile equals 0. Don't need it in that format, do we? That's what we've written in one line. All of this. So instead of doing that, what we can do here is using our one. I don't like switches, you see, so I don't normally use them like normal people, I suppose. Case, no profile. You'll see how better this is any second now. Turn, case, yeah. The next one would be core profile. Core profile. These are all documented, by the way. So it's in the documentation for QSurface format and case compatibility profile. Case compat no compatibility profile. I'm glad I'm dyslexic. There we go. Now we have defined that, we now have to undefine it, because we can't leave that lying around. This is another reason why I don't like it. Undef case. Okay. Now all we need to do is put that out to the screen. And I'm going to use QDebug. Be lazy, because it's easier. Q. Do it properly. This is how it's supposed to be done. Something called QPrintable. Why not? GL type. It's a macro. GL type. What does QPrintable do? It's part of the translation unit. I'll just leave you up in a minute. We'll come back to you also. It can go and look for it, shall we say? Da -da -da. QPrintable. And we will have our GL version. And we will have an open bracket. Don't want space there. No. Then I'll have QPrintable. We will have our GL profile. All I'm doing is exactly what was happening before. I'll do that, that, and it moves anyway. It's stupid. Okay, let's have a look at QPrintable for you. Qt Global. There we go. I can't see it. Where is it? Yeah, we have different properties, yeah. This is all under QObject. So it's part of the object abilities. QObject subclass supports Qt's translation features, making it possible to translate applications user interface. It must be wrapped in calls to the tr function. The translation, yeah. QPrintable also comes in there. It's not telling us. Blah 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 blah. You can find set of objects with find children, yeah. Returns constant char star equivalent to local 8-bit. All right. Right, it's just a conversion. Which one did we use? Just QPrintable by itself, didn't we? Which gives us a char star. So QPrintable just returns a char star. And we'll take, yeah. Yeah, it's just a converter for char star. And it still doesn't like it because we haven't got. Okay, that's okay. I'll just pop that up there for a second out of the way. What? Incomplete type is not allowed. Okay, I think it's on one of its humdingers. Did I do wrong? I didn't do anything wrong. Something wrong at the top. Why have we suddenly got a bracket out of place? Amber 3D. Amber 3D. OpenGL. OpenGL. I add a function and it breaks. Okay. Why are you breaking? Well, QPrintable just puts quotes around it, great. Incomplete type is not allowed. Why is that all of a sudden an incomplete type? I don't understand. Okay. Multiple errors have disappeared all of a sudden. Okay. Light in the wrong place. I think I put you in the wrong place. Cut. Yeah, there's your incomplete type. Okay. Aha. What? Oh, God, it's not this macro business. Messing things up. Problem is, I don't think that Visual Studio understands these macros. I don't understand why it's giving this crap. The message logger. That's all it is. I'll do it the other way. Percent S percent S colon open brackets percent S close brackets end string close brackets. Right, semicolon. Comma. GL type. GL version. And GL profile. And now it doesn't know printf. What is going on here? I'm really getting tired of Microsoft. What? Why did I bother trying to do this? What am I doing? I just don't get it. Simple code gives me the headaches. It won't print F anymore. Right, that's what I was using before. And it's fine. I don't understand what's going on here at all. Comma. GL. Why is this so hard? Type. Why can't I do anything with anything? Is that why I can't do anything? I've got nothing here. What's going on? It's blowing my mind. This is really blowing my mind. It's not allowing me to do anything after that hash define. Is it because of where I put my brackets? It is, isn't it? It's my bloody bracket. I've put that in the wrong place. All that was about was put that in the wrong place. Go on that line. Good God. One of these days, I am really going to have to sit down and sleep. It goes there. So, Q. Debug. Should work now. What's... Oh, right, never mind. Q. Principal. GL type. Now it's working. Yeah. It has to be a capital P on principal. It's a macro. Right, that's worked. Q principal. Godfather, this is getting slow, GL version. Oh well. Q principal, no. I'm gonna put that in. Wanted me brackets in just to split it off to make it look nice. I hope it looks nice anyway, that's what I'm trying to do. Wanted to show a different way of doing this, and this is it. Just caused me a headache. So it's that, and it's that. It moves everything, of course. So Windows 3D should now do a principal. Yeah. Do I leave that context in? Yeah, I may as well. Just for completeness, it doesn't actually need to be there. Okay. It's in initialize, so I'm not too bothered. There we go, OpenGL 330 NVIDIA 44587 330 NVIDIA. Thank you. Now we have the proper OpenGL. all that just to get a proper OpenGL readout. But yeah, that's nice. That's working. But that's working a lot better than it was before, because this is now can go across platforms, whereas before we couldn't with 3.3. But now we can specify it. And all we need to do to not specify it or change our OpenGL type is in our main program to specify a different type. Yep, that's it. So we've now got control over Microsoft's OpenGL, as well as Linux, as well as Macintosh. Whereas before, we only had Linux cooperating with us, and everybody else didn't like it. So there you go. That's how you change it all. Get a nice, decent, happy printout from it all. Now let's just give you that code, because I think that's a full update on the window. That's a window that's working. OpenGL update. Yeah. Correction to cross platform OpenGL. There we go, we can commit that a lot. And synchronize it. And you can have it. Magic. That's step 1 today. I think that's the window done. Step 2 today is starting our transform file. Now, transform 3D, I thought was going to be given by Qt, and it isn't. So I'm a little bit surprised, because the Q transform that they do give, after researching it, is 2D, or 2-dimensional. So I had to go away and think about how I want to do. Oh, it's OpenGL, isn't it? It's maths. I had to go away and find out really what I wanted to do about it. And the answer is, let's write a file for it, transform. Let's do our own. So transform.h. Stuff it. Why not? So I'll add you. Hello. Right, you're coming at the bottom of you. Alright, and let's add a new item. CPP file. Transform. .cpp. There we go. As simple as that. After my struggle to understand how brackets work, now you can see why those brackets are important. You have to keep things within context, and within the brackets in the same context. Ah, lovely. Now, how do I want to approach this? I think we're going to approach it step by step in probably my befuddled way. And if people can follow that, people can follow that. If they can't, well, sorry. I don't make sense at the best of times, but I'm hoping that if you have questions about this transform, because I spoke about it on the last episode, I tried to explain some of it at least, but it's not an easy one to get your head around at times. So our transform class has to do our transforms, obviously. Let's have a look. Just borrow you a minute. Right, we're namespace maths for this. Okay. There we go. Second of June, Christ. Here's something really silly. I mean, I'm on second year and we've got all the base. And we're now writing a game. Wow, by the end of this year, we're actually going to have the base game. That's amazing. Stop daydreaming. Ah, yep. Goddamn thing. Hash include. Oh, making a mess here. Put that away. Okay. So we've got our transform.h. What do we want to do? Yeah. What kind of structure can we have for this? Well, many structures, really. I'm just wondering where to put 3D on this. No. I prefer this. Alright, what do I know it's going to use? Let's start there. Let's start with thoughts. Qt provides us with quite a lot of stuff, which we can include. Obviously, he's got. And yeah, I'm only using one hand, sorry. So I know I'm going to need 3-dimensional vectors. That's a definite. I know we're going to be using the quaternions because, well, hell. Yeah. Why not? Let's program in 4 dimensions today. It's quat. Quaternions. Hash include. We will also need a 4x4 matrix, I think, somewhere in here. Is this going to clash? No, it can't clash. I've protected it, so we can just use transform. Right, okay. That's it. What's wrong with that? Public. Ah, class. My brain is not working today. Don't worry about it. That'll work a bit better. Yeah. Not sure what I'm going to put in here. I'm not going to mark it as empty this time. Just for a second or two. Right. Let's do this the wrong way round, because this is how I program the wrong way round, by the way. Always have done. I've always been backwards. I've always been backwards going forwards. So there's our transform. Let's make... Just trying to think. Right, let's start with the basics, and the basics were in here. Right, these are the basics. You rotate, so you translate, you rotate, and you scale. So translate, rotate, and scale are the next things we need to do. And then we can replace all of this lot with the correct things. Right. That sounds good. Hopefully we'll be able to get something to spin around its alternate axis. That's what this is all about, folks. I might do this a different way, though. So I will do a void transform. And first one. That's view matrix, not view matrix, not model matrix. First one is translate. So that's what we're going to call it. To translate something, we will need const q vector 3D, and we'll just take the address of it, inline. So delta change in t. Can't put dt because that's delta time. Delta translate. Do not abbreviate. Yeah, okay. Oh, I'm gonna do... Am I gonna do production code, or am I gonna just do the normal stuff? Production. Equals true. M_translate. I had to make a decision, sorry. It's going to look a bit weird. Plus equals delta translate. Translate, there we go. And that's it. So we need now two variables. mdirty and mtranslate. Q. No. We'll start with bool. M_dirty. It just tells us whether something's been used or not, or something's changed. That's all that has changed. Here's another way of doing that. Translation. And we just used an address of it, didn't we? Yep, so we're okay to do a Q vector for 3D. Like that. That simplifies our code, because now what we can do is we can just put in that our translation, right, we can actually put it in there, can't we? Wait a minute, what happens if I click on that? Oh, he does it for me. Well, I never knew it went the wrong way round, so this is going to support me, is it? I've quite... Translate, what have I called it? There we go, everything's happy now. So it looks like it doesn't do anything, but it does. It translates. It will translate a QVector 3D. How's that going to work? Well, we've got green blobby. Oh yeah, variables. Okay, we'll pop that in there then. M_dirty to false, please. Still not happy. Translate. Actually, I can probably put that as a comma. No. As a comma. Translate. And we're going to make that equal to a Q vector 3D, open brackets, 0.0f, comma. We'll set it to the center of the universe, 0.0f, comma. Hello? I can't hear anything, sorry. I'll put the phone down. No idea. 0.0f. Lovely, I'll do it. Right, so can shush now. That green light will take ages to disappear. I don't know why. Okay, so I set that up. There it goes. It's happy now. So it's translate, rotate, and scale. So the next two things I want are rotate and scale. So how should we do these? End. Just pop you down there. Oh, stop bloody altering where I put things. Stupid machine. Rotate. Alright, we will take in a const Q quaternion, quaternion. The people that want it pronunciating properly. And this is going to be delta rotate. Okay. Now, rotation, yeah, just do it the same as before. M dirty equals true, which means something's happened. What else can we have? We'll have to have M rotation now, won't we? Equals, get this the right way round. Otherwise it cocks up. Quaternion first. So that will be delta rotation. Or rotate, should I say. Delta rotate multiplied by M rotation. And that's how difficult it is. It all sounded so complicated, didn't it? We will now need to make an M rotation. An M rotate. M rotation. I want to keep my variables the same. Yeah, they hold rotation. That's a rotate, yeah. I need a rotation. And what is our rotation going to be? It's going to be something or other, I don't know. Let's make it a quaternion. Quaternion. So we can store it as a vector and a point. Is what, or a vector and a scalar. By the way, if you add up all the numbers within a quaternion, they will always equal 1. It is an identity vector. It has to be, or it has to be an identity. Just something I remembered now about quaternions, which are quite interesting. So the W is the first, which is the amount of rotation, or a percentage of rotation. The X, Y, Z are all 1, 1, 1, or 0, 0, 0, or 1, 1, 1 times that, or part of 1 times the W number. But that's not quite true, it's angle over 2 in radians. But never mind. Yeah, I think we'll have that. We are going to need a scale as well, aren't we? So we'll do that whilst we're here. And yes, it's a Q vector 3D. Why that? Because we can have different scales in different directions. We can bend and manipulate. Yeah, just call it scale, stuff it, I don't care. Right, okay, that's rotation and scale. I'm going to need a matrix of some kind. Alright, Q matrix 4x4. I'm just going to call this the world matrix because that's what it is. So I need to know the world matrix. Yeah. That's all I should need. So rotation scale and world. Oh. Comma. What have we got here now? I'm not doing that one. Rotation I'm not doing. Scale I can do. And that's going to equal a Q vector 3D. And that's just going to be 1.0f. In other words, size of 1 in the x-axis, size of 1 in the y-axis, and a size of 1 in the z-axis. Z. Yeah, that'll do. Other things I want to do is I want that m underscore world dot set to identity, and our rotation m underscore rotation yeah. Is there a dot set to identity? No. I don't think we have to do turning after that, do we? Yes, we do. It's a function. That will set that to identity. So those two, that's how you set a quaternion to identity and to set the world to an identity. So that's them two done. That's all of the things we're going to really need. Yeah, we'll take that. So that's the rotate. Well, let's try this one now. You can see a pattern starting to arise, I hope. Well, I hope you can anyway. But these aren't really doing much. Well, that's true. The scale is going to take in a const. Means we're not going to alter it directly. U vector 3D, and the address of delta change in scale. That'll do. Let's see now. Again, start with m_dirty. I shouldn't really use that word, but I mean, what can you? It's just a throwaway variable. And m_scale. Equals. No, it's times equals. It doesn't matter which way around these go, does it? Not really, I don't think. Delta scale. There we go. That's all it's going to do. Okay. I'll make one of those. Now we need to use them. Yeah. We can add some different things, really. I'm going to add something. Especially at the scale. Yeah. We'll add a feature. One that we haven't talked about, but I've just thought of, so I'm going to have it. I don't know if I'm going to use it or not. I think we are. So it's void transform. It's not scale. It's grow. Especially for things like trees, plants and things that I'm going to be using within the game. That's going to take in a const vector scale. It's the same as this one. There. But it's going to do something slightly different. Do it. m_dirty equals true. Anytime you take an action, always do that. And mscale. And this time I'm going to plus equals the delta. So it grows rather than increases by a scalar factor, like timesing by 2 or 3. You can just say, oh, I want to add just a couple of centimeters to that dimension. So yeah, you can do that as well. So plus equals delta scale. There we go. So we'll have that one. Looking good. We're filling this up nicely. With lots and lots and lots. There's going to be quite a few here. Let's do some setters as well. Getters and setters. Right, setters, let's have a look at these. Void. Transform. Set. Translation. We'll take in const translation. There's that one. Change in translate. Yeah, that reads right. And for that, we're going to, of course, 30. All's true, because it's changed. We're making a bucket just like we did with the input, but it's not as big a bucket, this one. It's just like a storage area for your translations and which way up you are and all the rest of it. So let's see. I've done rotation and translate. That should be translate. Not reading right. Okay, that might read right. Changing translation, yes, that reads right now. Changing rotation, changing scale, yeah, that's starting to look good. Just change that one. That reads right. Alright, I'm happy with that now. Pretty you, pretty you, pretty you, pretty you for a second. And what formula can I put in here? It's just setting, isn't it? So it's M translation. Oh, right, yeah, I know why. Equals delta. And we're just going to do the simple way of doing things, translation. So, just keeping everything nice and simple. So that sets the translation. Yep. I'll do getters in a bit when I can think about them. Oh, righty, so we've got you. Are we going to bother with the rest? Yeah, why not? Okay, let's do the first one. So this is set rotation. And we're following exactly the same kind of thing. How are we going to set rotation though? Yeah, we're going to use that quaternion thingy. That one there. Use you. Copy you. Copy you in. Thank you. So, m_dirty equals true. Always equals true. You're thinking to yourselves, well, when does it equal false? Well, when everything's been done and checked. Yeah. So set rotation is just m_rotation equals delta rotation. Okay. Yeah, that'll do. The last one is going to be set scale. Running set growth. No, you can't set a growth rate. Not at this point. So set scale is going to be the same as scale here. There we go, that's done. Lovely, added. So really, we haven't done much. All we've done is defined what kind of actions we want to happen. And that's the trick to this. Scale equals delta scale. That's a trick to this way of programming. This is what I call finalizing code. You normally have to mess around with stuff in development for ages until you get to this stage, so don't worry about it. Just don't worry about it. I mean, this is no messing. Simple getters and setters going up. So that's our setters done. Those are the only three I want there. That's right. Right, let's do some getters. Let's do an awful one. So what we're going to do is a const q matrix for x4. We are going to have and address. No, yeah, I just want the address. That's all I want. Because we'll probably, yes. So let's put that inside scope, transform. Scoping to transform. We will call this get matrix. That's what it is. What we're going to call that. It's nearly got it right. It tries, bless it. Bless it, it does try. Right, we've got to do some programming now because we need to create a matrix. So, this is when everything has been done, you will get the matrix. So, this is where we can, this is our final. When we get the matrix, obviously we've done all of our translations, our rotations and our scales. So we'll be able to do that and then just get the matrix itself. So equals false. That's that. M_world, always, always, always. Or working on a matrix, set it to identity. Doesn't matter if it's been done before or not. Set it anyway. Then we want to do M_world translate. One second. Got a cat meowing, it's just disturbed me thinking there. Okay. Get them in the right order. M_world. And it's dot. Yeah, it's part of the matrix things. Right, translate, yeah, got it now. By M_translation. Does that bit. You can see how disjointed everything is when you do it this way. Everything just becomes very disjointed and you can't see the full picture half the time. Rotate, hello. Rotate by M_rotation. And that will accept quaternion quite happily. And M_world. Last part of it. Dot scale. And M_scale. Doesn't it look simple now compared to what it used to be? So there we go. That's how you get a matrix. So now we can do that. So we can translate, we can rotate, we can scale, we can grow, we can get a matrix. We can set the translations, rotations and everything. Starting to make this kind of thing over here, looking a little bit redundant maybe? Get matrix, yeah. What, love? Oh. Have I left you any food? The rotten buggers. But you can now start seeing how I think it's going to happen. I think that's really roughly about it on CPP. Anything that we've missed? Alright, let's fill in the rest. Could do these in here. I'm just wondering. Could we put the rest of the getters in here? And setters. God, there'd be so many. No, I'll stay with those for now. Getters. Okay, accessors. Getters. Do we need any of the setters? No, not at this stage, we don't. Do need some more getters though. I'll put these here. No. Const. Q vector 3D, isn't it? Q vector 3D. And, because I want the address, and this is going to be get translation. So I can find out where things are. That might help. Should I do this on a separate thingy? No, not really. Const. Did I put a return in that? Get matrix. Did I? Not. Am I going mental? I think I am. Alright. We'll do that. We'll use it properly. And return m_world. There we go. That looks a bit better now. Yeah, I am a lot happier with that idea. Jesus. Nearly goofed that, didn't I? There we go. Let's return m_translation. What? Why did it do that? Microsoft is trying my patience. Alright. What will we need next? Yeah, problematic. If we want to get the rotation, it's going to have to come out as a quaternion. Yeah. I'm sorry, but it is. A quaternion. And get rotation. Const. Return m_rotation. These are all simple stuff. Nothing in here is going to be drastically, massively super duper. It's just going to be a straightforward transform class, which I can then alter later on. But I'm just writing it properly for once. That's all. Scale, Q vector 3D. And that will be get scale. And that's return. I won't have to redo this one, I'll just have to add to it. Scale. Hopefully there's nothing in there that's difficult, because if you remember that we had to make a matrix in create view matrix. Yeah. Well, all I've done is done the rotation, the translation, not view, model matrix. Sorry. I've done translation, rotation in three dimensions, but we're doing them all at once in this case, and a scale. This transform does all of that. Translate, rotate, scale. And we've added an extra bit. We can make the matrix out of it. So now we can make a transform component for our ECS, which will take this out of the equation. And that will make the, well, once we've got it working, create model matrix will disappear. Because it won't be needed. This will be able to do it for a component. And we can have a component system that will do it for us on an entity automatically. And that's the point of this transform class. It just replaces everything that we did in this very simplistic create model. As you can see, it's a very simplistic create model. What we do is we pass in all the information, and then we set to identity, we go through the calculations, and we return the model matrix back out. Not very efficiently, not very fantastically. It says here, use degrees, not rads. Could be interesting to find out if we're still in that position. I think we are. I think we still use degrees on this, but if we don't, we will change it. But this should be in degrees, not radians. So I think they wrote the mass library in Qt in degrees because they realised that people don't want to use radians. Well, or if you do want to use radians, you can. Put it that way. It's your choice entirely which one you use. So that's your transform class for beginners. Very simple system. It doesn't do anything. You think the transform class would actually have to do something? No, it doesn't. It's just a storage class. It doesn't really have to do much. It has to store the information. The component system, the system for the component, will do something with that information. So, yeah. When I was setting, did I actually do dirty or not? I did, didn't I? Setters. Dirty equals yes, because that matters, because our system needs to check whether mdirty is how will it check? Well, it doesn't matter. You can just ask for the matrix, and if it's been changed, it'll recalculate it. Right, so how does this transform work? What we are going to do is we're going to set up a system that asks for get matrix. Okay, after making any changes that it needs to make. So the system will take our component, it will run it through a very, very simple test or update. Yeah, an update is the best way of putting it. And it will then get the matrix. And there's your transform. And your transform matrix all set. So when it comes to rendering, the renderer can just get the matrix instead of having to calculate it. It'll be there ready for it. And if it needs to be calculated, it already has been done. Or if it doesn't need to be calculated, it won't be done. Oh, that didn't work. And that's it. So it's just for efficiency. purposes that you put the dirty in. I might change that, because I really don't like the word. You see, to me, it isn't that. It's just M underscore has. Sorry. M underscore needs update. That's what it is roughly to me. Does that make sense? No. That's it. It has changed. That's a lot better. I'm now happy with that. Yeah. Now, does that read better? Okay. So if we change a value, it has changed. So when we check to see whether, when we get the matrix, if it has changed, then we recalculate it and return the new one. Otherwise, we just return whatever's there. It will save us a lot of calculations over time, especially on static objects which don't move. We'll still have a transform, because they need to be placed in the world. Even if they never move, like a house. Never doesn't move, unless it's a mobile home. And yeah, that'll do it. I'll do all of the transforms using quaternions. Did you think it was going to be difficult? Well, Qt does it for us, so we're not bothered. We don't really care. So yeah, that's going to be our replacement for that. Create view matrix. I think it's just cursor. I'm not too bothered about that yet, because it's the camera. And we haven't changed our entity system for the camera. In fact, I don't think we are going to be using that camera. I think we might be using a different one that follows the same rules as the transform system. Because I'll show you how to use this transform system with a camera. How about that? We'll do that next time. We'll have a proper camera then. That would be fantastic. So instead of having camera, what I'm thinking next time is we can make a new item. This will be tomorrow morning, by the way. And we're going to call it camera 3D.h to distinguish between types of entities. That's a basic camera just for viewing things with. It can't wander around the world too well. It can go in directions, but it can't look up. It can't look up and turn at the same time. This one will be able to do so, so we'll add this. I think that's going to be a good explanation. It's also going to be a bit more complicated because we're probably going to see this quaternions being added into the system at the same time. But this will then give us a basic code for any kind of rotations that we need to do for anything later on. So we could do, well, it will give us the system that we need for rotations. Our camera is a special entity, so I want that separate from our entity system, because our camera is going to be part of our player, or it is our player. So we have to be more careful with this, and it needs to be outside. I want it more outside the system so that I can design the player properly without the entity system getting in the way. Because the entity system is for generating things on the fly rather than being the player. We might put the player as an entity as well. Probably will. I'm not even sure that this code will be used. That I'm going to do next. Interesting. Let's have a look what we'll go. Let's construct this. I have that. Yeah, we'll just have that bit. Oh, that's better. Yeah, take that. Alright, okay. It's probably going to use those three again. So I'll pop those in. Shouldn't have popped them in yet. Duh. Alright, that's set up now. That's where we're up to. So, next time around, I'm actually going to write this. Not sure whether we're going to use a code, but this will show us the code that is required to make a 3D camera, rather than anything else. I think that's going to be probably good. Yeah. Let's think about it. Right, we're going to be using those three, so those three are actually contained within the other include, isn't it? So, include. Amber 3D / OpenGL maths transform. There we go. Yeah, I think we're going to use that transform and we're going to do something with it, and then we'll try and integrate this more and more into our entity control system after we've worked out the kind of calculations that we're going to need to do. I mean, it's simple if we keep it simple. It's difficult if we try to make it difficult. The problem that I'm coming across with this is I have a camera 3D. Am I allowed to use it? Yes, I am. Right. You'll see what I mean with this when I start it. It's going to look a bit strange because we're going to need some consts. Yeah, this will work. This will work okay. I'll do it this way. What I'm thinking is the consts we can put in here. We'll be fine. We'll be fine. That's where we're up to. That's what I want to concentrate on next, is how to make this camera 3D. And then we'll be okay. So let's just build. Make sure my transform hasn't got mistakes in it. Okay, alright. We are fine. Doesn't look as though I've got any mistakes there, but we won't be able to test it until we put this together. And then I'll just throw a camera out with some controls, artificial controls on it, and we'll see how that works. Awesome, awesome, awesome. There we go. That's today. We now have transform sorted, or a transform, well, library sorted as a piece of maths. And now we're going to experiment with a 3D camera instead of this rubbishy thing here, which really, really, really does not rotate at all. Just has a position, increased rotation. That does not increase rotation. There's no quartz there, quaternions there at all. That will gimbal lock, it'll do all kinds of weird things, and it will be stupid. So no, we're not going to be using that camera. That's a definite. What I might do is create a full camera, test it, and then strip out its movement or how it works and put that into a component. Yeah. And then this will just become an entity then. I think that might be better. Okay, I've got a way forward, so we're going. That's where we're going to head next. We are going to look into this horrible turning idea. If you don't know anything about gimbal lock, rotation. No, sorry. Open GL rotation gimbal lock. this is crap. Just use quaternions and it stops it. There is a problem with quaternions though. So yeah, there's your explanation there. So it's when you pitch up, you've got a heading, a 0 heading, 90 degrees rotation about the X. This is a common gimbal lock configuration because if the aircraft keeps pitching up through the vertical, the heading suddenly changes from 0 to 180 degrees. And that heading can't be done. Rotation about the y-axis. And you can't rotate about the y-axis because you're looking down it. It will roll you. And you can't do it. Yeah, drive pitch, that causes gimbal lock. Yeah, that's right, because you can't get past the 0 due to the fact you're using cosines and sines. It just doesn't work. But yeah, Euler rotations, yeah, okay. But we're not going to be using Euler rotations, we will be using what? Quaternion rotation. Right, I'm happy with all of that. If you know, if you want to learn more about all of this, let me know. I mean, I can sit down and teach you, do teaching sessions. Khan Academy. Okay. Khan Academy here is free, it's online, and very, very good maths for game programming, and they will talk more about gimbal lock in there. So, a good place to go, log in, sign up. Big shout out to Khan Academy, they helped me out a hell of a lot with gimbal lock and this situation. So my understanding of it is from memory, but it's when you hit an axis, when you are facing straight down an axis, it usually happens when you look directly up. One of the options is to stop people from looking directly up, the other option is to do it properly. So we're going to do it properly. Khan Academy, big shout out. And let's give you your code. You can have the code and you can play around with it. See if you can come up with anything better. If you can, let me know. I think that's pretty straightforward, isn't it? So this is transform in 3D added. To avoid gimbal locking. It uses quaternions. There we go. And you thought it would be complicated? It isn't. All we did was change one function, and that was the rotation function. And all we did was put quaternions in instead of vector 3Ds in. That's it. There's nothing complicated about quaternions. There's nothing scary about 4 dimensions. There's nothing scary about 3 dimensions either. It's when you get to 5 and 6 dimension calculations, that's when it gets scary, and yes, I can do them, so don't go there. They are scary. It takes me a couple of days just to get the problems sorted out and basically set down when I do those. So, I think we're in a good place. I think we now have a cleaner window. I'm leaving all the stuff in window. for reference when we come back to our world builder. Because this will change our world builder massively. Because we will be able to then use an entity system in there as well. Or we might rework the world builder into the test game itself. How's that for an idea? I hadn't thought about that before now. Okay, I'm off. I'm going. Goodbye. Take care. Take care. Play with the code. Have fun. I'm still not well at the moment, so bear with me. I'll try and get something up on YouTube every morning if I can. But this afternoon I will be on Twitch. I'm just going to be relaxing and I'll shoot a few ships or something. I don't know. I'll do something silly. Come and join me on Twitch if you want to see me on Twitch. I'm at Razor Blade Sharp, funnily enough, on Twitch. There you go. Pop in, have a laugh, talk, you know, chat with me. I'm not bothered about the game that I play. If somebody wants to come along and chat with me about programming, I'll sit there and chat about programming all day. I don't care what I do. So, yeah. Take care. Have fun. I did put that forward. No, I didn't, did I? I'm done. Did I sync it? I do things and I can't remember, you see. I have notes on everything. That's what I've been doing the last week. Right, yeah, we're okay. You've got the code. Tomorrow, the camera. And it's an interesting problem. I've got my notes written down, so I understand the problem. And bye for now. Have fun.